This video is on National Grid. Now, National Grid is an interconnected network which delivers electricity to our homes. It starts with a power station. Okay, I'm just going to go here. Say, as you can see, it starts with a power station here. So what does this power station do? It generates electricity either using a windmill or nuclear power plant or a solar power plant or by burning coal, renewable or non-renewable resources of energy. So power station generates electricity, and then next to power station is a step up transformer. Then we have these cables that transmits electricity from the power station to the homes. Then these towers that you can see, they are called pylons. And then you have a step down transformer and then the consumer. So sometimes the questions would be like, what is a national grid? What is national grid? What are the components of national grid? So it is just an interconnected network that is connected to a power station and to the end consumer. Now, why does a national grid has a transformer? And what is a transformer? So a transformer is, so before that, we'll just see what is a transformer. So transformer, what a transformer does is it either steps up or steps down a voltage. See, so that is now tells you how many types of transformer are there. So there are two types. One is a step up transformer, another one is a step down. So what does a step up transformer does? It ups the voltage. Okay, so it increases the voltage, and this one, it decreases. Down is decreases the voltage. Don't get confused. Down is decreased but not decreasing current, it decreases the voltage. And now because the power remains constant, okay, whatever power is going into the transformer, so whatever power goes here, the same power comes out. Okay, so if the power going in is at high voltage, okay, so let's just go here. So if the power is same, is if the voltage is high, the current decreases. So increases voltage, that means it decreases current because the power is constant. Say now this one, if it is decreasing voltage but again the power is constant, so what would happen to the current? Yeah, you're right, it increases current. Okay, so okay, now the question that you need to know, what remains constant in a transformer? Whatever power goes in, the same power comes out. Whatever power goes in a step down transformer, the same power comes out. Again, we're assuming that there are no losses. So now if the power is constant, a step up transformer increases voltage and decreases current. A step down decreases voltage and increases current. Now, why do we need to do that? That's the big question. Now, why do these transformers are very big electrical things and they are expensive. So why do we have them in the national grid? Okay, the first reason, why do we need a step up transformer? So step up transformer, what it does is, because it decreases the current that is going into these cables, which are huge, they're very, very long, sometimes in kilometers. So such thick cables in which a huge amount of current, if the current is very high, this current produces heating effect. Whenever there's a current flowing in anything, that thing gets heated up. Okay, if you're charging your mobile or you're charging your laptop, if you touch the adapter, that adapter becomes hot. You're using laptop for a long time, the laptop becomes hot. You use mobile for a long time, it becomes hot. So anything that through which a current flows, it becomes hot. Now electrical companies that are generating electricity, they do not want the heat produced in these cables. So if there is a heat produced, there will be losses. So decreasing current, what is it does is decreases thermal losses. Why do we have thermal losses? It's because the wire has a resistance, and whenever there is a resistance, I'm going to write the equation here. Power is I squared times R along with VI. This is another formula for power. So as you can see, R is a resistance, I is the current. If the current is very large, the thermal energy losses per second would be very large. So we decrease, the step-up transformer decreases the current to decrease the thermal losses and to increase the efficiency of national grid, isn't it? If there's less loss, you're producing something. Let's say you have a company, and that company is designed to produce electricity, and you are creating 1000 kilowatts, okay, and the consumer, which is hundreds of kilometers away, it ends up getting only 100 kilowatts. You have lost 900 kilowatts as thermal losses in the cables. You wouldn't want that. You are not cashing on that. You're producing 1000, but you're selling only 100. You've lost this. You don't want that. So how can you reduce that? By using a step-up transformer, a simple thing, which decreases current, decreases thermal losses, increases the efficiency. Okay, why did I write loss here? Now, before this question, okay, let's just quickly do this question. Why is it used? It is used to increase voltage so that the current decreases and to reduce energy losses. Do not choose increasing current. If the current increases, the heat also increases. Now, then why do we need a step down transformer? A step down transformer, so you have, now this is a very high voltage. You know how much voltage it is? Somewhere around 66,000 volts. If that high voltage comes in our house, our devices would be burned. So we don't want that. So what do we do then? We attach a step down transformer somewhere near the consumers, and so a step down transformer, then it decreases that extremely high voltage to a voltage that will be safe for the consumer. Say this one is then reduces the voltage to, what is the voltage in the UK mains? It is 230. So it reduces the voltage to 230. So then what would happen to the current? It would increase. So what a step down transformer does, it decreases that extremely high dangerous voltage and then increases the current so that it is safe for the purpose of the consumers. So safe for houses or the consumers. Okay, houses and appliances. You wouldn't want your TV to get 66,000 volts. That would be very dangerous. Say another question on the same step up transformer. Why is electrical energy transmitted at a very high voltage? It's to reduce power loss in the cables. Now try to pause and do this question. It's the same thing on step up and step down transformers. Okay, if you've done that, make sure if you've written step up and then step down. Step up increases voltage. You can just go back and check here. So this is step up and then this is step down. Now, this one is a calculation question. This is mostly to the students who are doing higher. Say, let's just see. A transformer has 200 turns. on the primary coil and 1,000 turns on the secondary coil. So what happens is, in a transformer, you have, so I'm just going to make a transformer here. Say this is a transformer. A transformer is nothing but a solid iron core on which you have these windings. This is a wire, and then you have a wire here. See, this is where the current goes in. So this is the input, and then this is the output. Okay, now if the primary turns has 200 turns, so the input wire is called the primary wire, and the output is the secondary coil. So normally, whatever number of turns are there in the transformer, so this one has 1,000 turns. So if the number of turns is becoming 5 times, that means it's a step up transformer. The voltage also becomes 5 times. So if you're giving 12 volts here, this one would be 60 volts. So that's what it happens. So number of turns would decide how much a voltage would be the output voltage. Now, for example, so this is a step up because it is increasing the voltage. How is it increasing? Because the number of turns are increasing. Now, if I have another transformer, okay, the one which is closer to the consumer house, that transformer has, let's say, 200 turns here in the primary, where you give the input, and the output is somewhere here. You have the output, which is, let's say, 10 turns, very small number of turns. So this is your secondary. So you'll see what happens to the number of turns. The number of turns, what has happened to the number of turns? It has decreased by 20 times. Okay, so it has become 1/20. So if the input voltage is 6,000 volts, the output voltage will be 6,000 divided by 20, that is 300 volts. So whatever happens to the number of turns, the voltage gets multiplied by the same ratio, right? So that's it. So that is, okay, let's do one more question. Suggest and explain 2 ways engineers reduce energy losses in the national grid apart from using transformers. Now, what is the cause of energy loss? The cause of energy loss is the heat produced in this. So this is I square R losses. So if I can somehow decrease the resistance, say a thick wire would have very high, very low resistance. So using very thick wires would have less resistance, and also, so I'm just going to go back. Okay, so one is somehow I can reduce the resistance. So I can reduce the resistance by using thick wires. So very thick wires would have less resistance and hence less thermal losses. And these days we have very higher advanced level conductors. So the conductor, it's a very good conductor, it would have very less resistance. So using better conductors of electricity. So the better the conductor would be, better the, less the resistance, and less the resistance, less is the thermal losses. Okay, so that's it. So we're just doing national grid and transformers today. Keep learning. Well done. Thank you.